So here's what hopefully your map is starting to look like. And then I stopped here because, well, we get down, so you should have contours at 50, 60, 70, 75, 80, and 85. But then we get to these pesky 90s. And what we see here is we've got, 4 90s here and, another group somewhere over here. And so then we have to think about what will we do? If we go up and then down and then up, what does that say? What inference do we make about this area here and this area here? If we go up and then down, we're saying that this is higher than 90, and remember we're fencing out and fencing in, and that would make this area of Texas right here a little lower than 90. Well, I don't know if that's an accurate inference. So if we went down, then up, then down, we have that same problem. We're saying this is higher and this is lower when we really just don't have data. So the easiest way to deal with these 90s is to go ahead and take and loop them. So now as I loop them, though I've excluded this over here, we don't have data over here. And so what'll happen a lot is you'll see a meteorologist, and they might give you a picture that looks like this portion of the map, or they might give you a portion that looks like this portion of the map. And you'll just see them kind of conveniently cut off a certain area because they just don't have data for that area. And so that becomes a tool that the meteorologists will use to kind of mitigate that. So here I'm going to go ahead and draw another 90° Fahrenheit area, and now when I shade like I shaded the others, what you'll notice is you kind of run out of colors. So I've used all these other colors, and so when we used a computer program, you would fill in that white area with another color. So no matter what, your whole map looks colored and pretty and glorious, and ta-da, there's your weather map. Doesn't matter what colors you used, that's more for your personal aesthetic interest than for anything else. In meteorology, they usually use warmer colors for warmer temperatures and cooler colors for cooler temperatures, but whatever makes you happy. Now the interesting thing about this map is it's pointless, absolutely useless for the meteorologists. They produce this solely for the service of the people watching, for their consumers. So this is so Grandma Rachel knows whether to send little Jimmy off to school in a parka or in a jacket today, because she'll know what the temperatures are going to be like. For the meteorologist, this does very little other than to help us identify where maybe some warmer or colder air masses. So up here we see we have a colder air mass kind of somewhere in this general area, maybe up over here, and we have a warmer air mass down here in Texas and down here in Florida because we can see where those temperatures are. Everywhere else we don't really have any bubbles of air that we can identify as an air mass. So this map is relatively useless for that meteorologist. It's this next map that becomes the most important. This one's an isobar map, and we're going to treat it much the same as we did the other one. The difference that we're going to use, though, here is that we're only going to use one color. You know me, I like my purple, so I'm going to use purple as my favorite color. And now we're going to go ahead and draw some contours. I'm going to recommend that you start with the highest numbers and then go to the lowest numbers. So here's a good spot to pause this video and see if you can contour this map. Alright, as you come back, I'm going to go ahead and fill in the key so you can see if you did correctly. So I start on the west coast here because that seems to be the easiest. There's my highest numbers. And then I've got some 10,008s here. And then I get to the 10,004s. And so what I see here is I see some 10,004s kind of over in this area. I see some thousands, and then I see more 10,004s and more thousands. So what you kind of want to do is figure out how can I get from over here to over here. Well, the problem with that is we've got this area that is just 1,000 millibars. And so if I try to get from over here to over here, my lines are either going to cross or touch. And if I zoom out, remember, I don't want those lines to ever cross or touch because you can't have two different pressures in one area. So I'm going to treat these like puddles. I'm going to leave a puddle of 1,004s over here, and I'm going to leave a puddle of 10,004s over here, and I'm just going to let those be two separate entities. So I'm going to just go ahead and draw this 1,004 here. I keep saying 10,000, sorry about that. And then I'm going to draw this 1,000 line here, and I'm going to leave those puddles just kind of as they are. So then I'm going to come over to this side. And first off, what I see is I've got kind of this line of 10,004s here. And so I'm going to go ahead and draw that in. And then I see this line of thousands. And then I see this line of thousands. But now what I've got is a 1,004 and a couple 996s. Well, I know that contours always form closed loops, so I'm going to go ahead and loop this guy to make a circle. And then I can start to make some inferences. Well, if that makes a circle, and I've got some over here and I've got some over here, I bet this makes a circle. And now if I drive in my car from here to here, all of a sudden 1,000 starts to come into play right there, and now I can finish that inference and go there. Well, and if this makes a loop and this makes a loop, then I bet this makes a loop. And I can start to make another inference. And so we have some closed loop lines. So there's our isobars, and now we're ready to answer the questions on the back. So if we look at these questions here, the first one, identify on our isotherm map. So where it says isotherms, what we have to remember about isotherms is that warm air masses, hang on while I adjust our camera, sorry if you're getting a little motion sick. Love you, Bergman. Okay. Where would there be a warm air mass? We already identified those. Those are those areas of red. So that's going to be then over that Texas area and over that Florida area. So that first question is relatively easy, and that's literally all that meteorologist uses those isotherm maps for, is for identifying where those air masses are. The isobars, though, that's the bread and butter of the meteorologists, because they can be used to identify highs and lows. And before, where I said it didn't really matter what color you used, we're going to be specific in our colors. I want you to use blue for high and red for low. We are going to be looking for those high numbers and those low numbers. So on our isobar map, label with a big blue H, the center of a high pressure area, and we're also going to label our low pressure area with a great big red L. So so this is a good spot to pause your movie while you get a red and a blue colored pencil or crayon. And fast forward, hopefully. Sorry. Okay, so I'm going to look for the place where I have the biggest numbers. And so as I kind of eyeball my map, I've already connected all the lines, so I just have to find the line that has the highest number, which happens to be over here, over San Diego. And I'm going to take and mark a nice, big blue H. Okay? And then I'm going to look for the lowest numbers, and that happens to be, and again, I've already labeled my lines, so I just kind of have to glance at my lines. I find my lowest numbers are over here over West Virginia, so I'm going to put a great big red L over that West Virginia area. Okay? Now, the beautiful thing about an isobar map is that the meteorologist can use that then to determine the direction that the wind will blow. And so looking at your map and looking at my map, they're going to be different just because we drew the lines differently. But what I want you to look at this point in the movie, and you can pause if you'd like, is to find the spot where your lines are closest together. So as I find that spot where my lines are the closest together, what I'm going to look, that's going to tell me my wind speed. So if I look at my map, I'm guessing they're going to be right about here. or maybe over here, or maybe here. Okay, so I have three possibilities. The thing is wind always blows from the areas of higher pressure to the areas of lower pressure. So if I was going to draw my wind line, I might put it here. And I'm being careful not to cross over that 1,000 line because over here is a higher number, so the wind's not going to go that direction. Or if I was putting my arrow here, I might draw an arrow going this way. And notice it's at a 90-degree angle each time to that isobar line. If I was drawing it over here, I might draw my arrow there. So they can go in any of the directions as long as it goes from an area of higher pressure to an area of lower pressure. It doesn't matter where you draw your line. Hopefully you chose one where your lines are relatively close together. And so you will then have some wind line drawn on there. And so that was one of your questions on the back. And so this was our arrow down here at the bottom. The last two questions relate to what kind of weather we see with those different forms of pressure. So high pressure regions are usually associated with dry weather. And so we would expect to see those clear skies over California, where we put that great big blue H. And then low pressure regions usually bring precipitation. And I'm just reading out of this box right here. Because when the air rises, it cools and the water vapor condenses. We would expect to see that over that West Virginia area, because that is where we saw that low pressure area. And that, my friends, is what we need to know if we are a meteorologist. So this reason right here is why those meteorologists all are versed in contouring and how to read a contour map and make a contour map. They're trying to determine this pressure gradient so they can also forecast the weather. So this map is the pressure gradient map. That isobar map is truly the bread and butter of meteorology. And that's one you will revisit time and again in this unit. All right, thanks for watching.